If you are still interacting with artificial intelligence by opening a browser tab, typing a long paragraph, and then copy paste the code back and forth into your project, you are leaving 90% of modern AI power on the table. That manual loop is too slow, it doesn't scale, and honestly, it's a massive bottleneck. In production, engineering teams don't chat with AI, they build a system driven by AI. Today, we're looking past the basic chatbot to break down the three pillars of production-grade AI engineering: prompt engineering, autonomous engine, and spec-driven development. By the end of this video, you see exactly how these three layers fit together to build systems that can write software, automate complex business workflows, and self-correct when things break, all under tight, reliable architectural guardrails. Let's dive in. Let's start with the base layer, prompt engineering. Now, if you scroll through social media, you probably seen people selling magic prompt or telling you that typing phrases like "take a deep breath" is the secret to unlocking the model. In production engineering, that's not what prompt engineering means. Prompt engineering is about structuring data, managing context windows, and forcing non-deterministic models to behave predictably. When you build an app powered by an LLM, your users aren't typing the main prompt. You, the developer, had called what is called a system prompt behind the scene. This defines the model identity, its boundaries, and crucially, its output format. See this, we are stripping away the model conversational instinct. We are telling it, you are an isolated data parser. Do not say, sure, I can help you with that. Just return the raw data structure we requested. We also use techniques like two-shot prompting, where we fit the model to a 3x example of inputs and desired output directly inside the system instructions. This establishes a rigid pattern for a model to follow. Think of prompt engineering as writing the architectural blueprint and rules. It detects exactly how the model must process information, but the blueprint can't build a house by itself. For that, you need the next layer. Enter automations. A standard LLM is entirely reactive. It only speaks to spoken to, and its journey ends the moment it finishes outputting a token string. An agent, however, is an active loop. You get the high-level objective, and it decides its own step to achieve it. Agents rely on an architecture known as tool-use or function calling. When an agent relies, it doesn't have the answer to a problem. It doesn't just hallucinate or give up. Its prompt is that it has access to specific tools, like a terminal execution environment, a database client, or a website API. Watch what's happening in this terminal loop right here. The agent didn't stop an achievement for help. When the test failed, it saw the error output, reflected on why it's happened, revised its plan, and executed the tool again to correct it. This accuracy loop is what makes it autonomous. But if you give an intelligent agent open-ended access to your code repository or your database, things can quickly turn chaotic. It might decide to rewrite your entire database schema or introduce terrible architectural pattern just to make a quick fix pass. To keep autonomous agent from going completely rogue, we need our third and final layer. This brings us to Spec-Driven Development or SDD. Instead of opening a terminal and telling an agent, hey, go build an expense tracking system, which is far too vague and dangerous, we practice Spec-Driven Development. Before the AI write a single line of application code, a human engineer writes a rigorous, highly detailed specification document. This is usually just a markdown or open API file that outlines the exact requirement, data constraint, boundary rules, and testing parameters of the feature. We fit this specification file directly into the agent context window as its ultimate source of truth. The workflow shifts completely. 1. The human acts as the system architect, defining the strict technical specifications. 2. The agent reads the specification and marks out a concrete execution plan. Point 3. The agent writes the application code and the unit test required to validate that specification. Point 4. The system is blocked from deploying until the agent successfully passes every single metric or line in the spec document. What is business logic changes? Say, our transaction limit changes from $50 to $100. You don't go rewrite the application code or write your backend logic. You simply update the specification document. The agent reads the new spec, realizes the code no longer matches the requirements, refactor the underlying code, update the test, and validate it automatically. When you stack these three tiers together, the developer role changes profoundly. Prompt engineering ensure the model talk to each other and your infrastructure in clean, predictable structural language like JSON. Autonomous agent execute the heavy lifting, writing the repetitive boilerplate, wiring up APIs, running tests, and managing error correction loops. Spec-Driven Development serves as a digital building inspector, keeping the autonomous loop entirely inside the guardrail of your architectural requirements. The error of copying and pasting individual functions out of an AI chat window is coming to an end. As you move into building production software with generative model, your value as an engineer isn't defined by how fast you can type line of code or memorize syntax. It's defined by your system thinking. The most effective engineers aren't the one writing the best code anymore. They are the one architecting the best system and writing the most flawless technical specification for agent to execute. If you want to see exactly how to implement this task by building a functional system from scratch, let me know in the comment below. Hit subscribe and I will see you in the next one.